Welcome to solverfy.
We are given the probability generating function for a random variable x, where x of s is a non-negative integer for all s in the set S. In part A, we are asked to prove that the probability generating function evaluated at 1 is equal to 1. So we have, by definition, the probability generating function for a random variable x on the sample space S, such that x of s is a non-negative integer for all s in the sample space S, is gx of x is equal to the sum from k equals 0 to infinity of the probability that the random variable x of s is equal to k times x to the k. So in part A, we have that gx of 1, this is equal to sum from k equals 0 to infinity, the probability that x of s is equal to k. And we have, by the property of probabilities, that this sum over the whole sample space must be equal to 1. And in part B, we are asked to prove that the expected value of x is the derivative of gx at 1. So we have that the derivative of gx at x is equal to, if we differentiate term by term, the sum from, and here I'm going to omit the first term, so this is the sum from k equals 1 to infinity, since it's a constant, of probability that x of s equals k times k, x to the k minus 1, and so we have that g prime x evaluated at 1 is equal to the sum from k equals 1 to infinity of the probability that x of s equals k times k we have that this is equal to, if we take k to be 0, we have just the term 0, so this is the sum from k equals 0 to infinity of the probability that x of s equals k times k. Recognize that by definition, this is the expected value of the variable x. This is what we wanted to show for part B. In part C, we're asked to show that the variance of x is g double prime x of 1 plus g prime x of 1 minus g prime x of 1 squared. So notice that g double prime of x, or g double prime x of x, is equal to, again by differentiating term by term, this is going to be, if we omit the first term, the sum from k equals 2 to infinity of the probability that x of s equals k times k minus 1 times x to the k minus 2 so we have that g double prime x of 1 is equal to the sum from k equals 2 to infinity of probability that x of s equals k times k minus 1. Recognize that if k is equal to 1, then this expression is equal to 0, and if k is equal to 0, this expression is equal to 0. So this is the same as the sum from k equals 0 to infinity of the probability that x of s equals k times k minus 1. And so we have that g double prime, or gx double prime of 1 and then plus gx prime of 1 minus gx prime of 1 squared this is equal to the sum from k equals 0 to infinity of k times k minus 1 times the probability that x of s equals k plus the sum from k equals 0 to infinity of, from the previous part we have this is k times the probability that x of s equals k times k, which we recognized was the variance, or the expected value, simply call it ex. And we have that this is minus, and again, gx prime of 1 is expected value of x, and this is squared. And we have that this is equal to, we can write this as the sum from k equals 0 to infinity of k squared, probability of xs equals k, minus the sum from k equals 0 to infinity of k, probability that x of s equals k, plus expected value of x minus expected value of x squared, and we see that first sum, this is the expected value of x squared. Second sum is the expected value of x. And so this all reduces to expected value of x squared minus the expected value of x squared. We recognize that by a property of the variance, this is equal to the variance of x. And this is what we wanted to show.